Welcome to Science Time.
Science time!
You may use the following materials to perform your experiments. Ready for your mission?
How do you slow down a moving object?
Should you run into trouble, you'll have 3 lab lines.
You need to ask the expert.
Let's take a field trip.
Guess we better visit the lab.
Something amazing happened.
Wow, that was cool.
Are we expecting someone?
Definitely not. Once science time has begun, we cannot accept any new visitors.
Hi. Yoga class let out a bit early, and I was just passing by, and I saw the sign on the door. Science time! It really caught my eye. Mind if I join you?
This is kind of an exclusive club.
Yeah, and everything we do here is totally top secret.
What's going on?
Hold on to your yoga mat. Things are about to get exciting.
Welcome back to Science Time. I see we have a new member with us.
Actually, I'm just passing by.
As you may or may not know, Lindsay, in science, everything happens for a reason. Take motion, for example. Something compelled you to enter this room, did it not?
He knows my name?
He knows everything.
Then you may be of some help to our scientist. Are you ready to hear your mission?
Yeah, of course.
You must answer the following questions. What is necessary to move an object at rest? How does a roller coaster work? What prevents motion or causes a moving object to slow down? In answering these questions, you will better understand Sir Isaac Newton's 3 laws of motion. You may use the following materials to perform your experiments: a marble, a toy racetrack, and this golf club and golf ball. Should you run into trouble, you have 3 lab lines: field trip, visit the lab, and ask an expert.
Are you sure I'm supposed to be here? I don't know the first thing about science or motion.
Then you're right where you need to be. Your time starts now.
This is gonna be fun.
Good, I'm an excellent golfer. This will be my ace in the hole.
I wonder what we're gonna do with these. The marble was at rest. And now we're moving it. But the question is, what's moving it?
Well, we are. But I don't think it's that simple. I mean, of course we're moving it, but how? Maybe we should use the lab line.
No, we just started. How about we figure this out first?
Yes! One more win for the Lindsay Mobile.
You got the better car.
You wanted the bigger one.
Well, clearly the smaller one is faster.
No way! Let's switch. I bet I'll still win.
See, I told you it was the car.
Now let's do it again. I'll keep the same car to prove to you that it's how hard I push it. Best out of 3?
Okay.
On your mark, get set, go.
Yes!
You just got lucky that time.
Okay, luck has got nothing to do with it.
So what's it got to do with? How is this getting us any closer to answering one of the questions?
Maybe we should keep racing to try and find out.
Hey, what's going on here? Golf lessons?
Well, yes, it is golf lessons, but I'm doing it to illustrate an object in motion. If we can find out what makes the ball accelerate and what makes it slow down and stop, we can come closer to answering the final question.
Accelerate, to speed up or gain momentum.
A little too much force on that one.
Wait a minute. Force. Force is what moves an object when it's at rest.
Force, a strength or energy that causes motion or a change in motion.
Okay, so if force is what accelerates the ball, then what makes it slow down?
Should we use the lab line, Robert?
Yes, in times like this, I always ask an expert. I really feel that's the
Cool.
safest.
Field trip.
How do you slow down a moving object?
Let's ask Tyler at the Da Vinci Science Center.
Here we have a wheel on an axle. Let's go ahead and give this a spin. It seems to be moving at a constant rate, but will it ever slow down or even come to a stop? Let's find out. Motion is a type of energy, and the friction between the wheel and the axle created heat. This is a different type of energy. The more energy that's lost from motion and turned into heat will actually cause the wheel to slow down and eventually make it stop.
Oh, so it's friction that prevents motion or slows a moving object down. Oh my gosh, look at the time!
Guys, you're just wasting time playing with cars.
We need to use another lab line. I got this.
I think I can help with that. When I throw a ball into the air, it's going to have two kinds of energy. The energy of going fast, which we scientists call kinetic energy, and the energy of being high, which we call potential energy. You see, the energy of going fast is turned into the energy of going high and then back again. Now it's the same with roller coasters, and wait until you see this. And I've enlisted the help of a friend who is going to hold up my make-believe roller coaster for me. You see, I've made roller coaster tracks out of this tubing, and we're gonna make a hill. Gonna make a hill with the roller coaster, and you're gonna help me out here. Now don't bite, wait a minute. Let's see, that looks pretty good. Using our principles of energy, if I were to hold the marble at a height which is lower than the height of this hill, do you think it's going to be able to get over the hill? Let's try it out. No, because it doesn't have enough energy of being high, which gets turned into energy of going fast, which gets turned back into energy of going high again to get over the hill. But now, what happens if I start it way up higher? Here we go. This time it can get over, because now we had enough energy of being high to get over this hill. We can't end up any higher than where we started. In fact, because energy is lost due to friction or rubbing, it can't even go that high. And now, let's see if we can get it to go around a loop. Oh, I'd say right about here. Here we go. And let's take another marble and try it out. And here we go. And that's why roller coasters start up high, to take the energy of being high and turn it into the energy of going fast, which is the fun part. But uh-oh, guys, I think I lost my marbles. I better use my energy to find them. But you guys, see you next time.
I get it now.
Me too. Once a roller coaster reaches the top of the hill, gravity takes over. It accelerates as it goes down the hill, so potential energy is turned into kinetic energy.
Congratulations, you've completed your mission for today. Let's review.
The first law of motion states that an object already at rest wants to stay at rest, and an object already in motion wants to stay in motion.
And only force causes motion or change in motion.
The second law states that the bigger an object is, the bigger push it needs to accelerate.
Right, like a roller coaster. The acceleration of an object depends on how much force is put on it and how much mass the object has.
Third law of motion states that an object, like a golf ball, is very sensitive.
And they always react to what happens to them. As Sir Isaac said, for every action there's an equal and opposite reaction.
You have done well, scientist. Till we meet again.
Great job, guys. This is amazing. Until we meet again.